I am Dr. Ravina Priyadashni. In this class, we shall discuss about the thermal control and propulsion in satellite communication system. So let us consider the satellite is revolving around the Earth. So the satellite will receive the radiation from sun and also some amount of light heat signal from the Earth surface. Apart from that, it will be suffered due to albedo effect. So albedo means the fraction of light signal that is reflected back from the Earth's surface is known as albedo. So just in this figure, just the satellite is revolving around the Earth, so it may get receive signal from the light signal or the heat signal from the solar sun, as well as the radiation from the reflected light signal, heat signal from the Earth, as well as the signals from the Earth's atmosphere. So here the equipment in satellites also within the satellite will also generate some heat. So we can say the heat that will be affect the satellite is of two types. One is the heat signal from away from the satellite, another one is the heat signal which is generated within the satellite. So the number of components will be there within the satellite. So the heat signal produced by the operation of the devices, it may also get affect the India operation. So this effect, that is the heat signal generated from the sun as well as the earth, this external effect has severity in low Earth orbits of satellites, and the satellite is launched in geo, it does not have a major problem. So we can say that there are number of preventive mechanisms are followed. So first one, it is classified two types. One is active method, another one is the passive method. So in case of active method, some thermal blankets as well as shields and radiation mirrors are used. So these are the thermal blankets and shields used. These are when the satellite, the elements of the satellites or the components of the satellites will be covered by these sheets as well as the protection blankets. So because of that, the excess amount of heat or radiation from the sun or other devices will not affect the internal parts or the components of the satellite. So next is the mirror. So this will also reflect back the solar energy from received from the sun. So because of that, the components within the payload will be protected. So these are about the active methods. Next is the passive technique. So the passive techniques within the spacecraft, thermal balance can be achieved by using some of the passive techniques. So these are the proper choosing of the materials. So for the construction of the various components as well as devices within the satellite, so that will be fabricated or manufactured by various components as well as materials. So the care should be taken while choosing the materials for the manufacturing of the internal parts of the devices. So in this figure, it indicates the various positions how the heat energy is get reduced in a satellite. So the satellite here in the position 1, we are fixing the optical solar reflectors, so that are placed in the north and south panel, and also the antennas are made from graphite epoxy. The purpose is that will reduce the distortion, as well as the multi-layer insulation is made on the rack side of the antenna reflector and tower to minimize the thermal gradients. And also, rear surface of the solar panels is painted in black in color to reduce the to improve the high emittance rate. So that last, the east and west panels of the spacecraft are converted with multi-layer insulation. So that's about the thermal control. Next is the propulsion. So propulsion, what's the need of the propulsion is propulsion subsystem is required for a communication satellite. The main purpose is to maintain the orientation of satellite in a correct orbit, as well as to maintain the spin rate of the satellite. Next, inject the satellite in the geostationary orbit in a designed or desired way, and maintain the satellite at the correct longitude in the equatorial plane by station keeping. Also help in altitude control of the satellite. propellant. The propellant is used for propulsion, and this propellant it can be a liquid or in gas form. So in olden days, the propellant they are used as the cold gas, and nowadays liquid gas are used as propellant. The next parameter should be known is the specific impulse. So this is the characteristic a parameter which is used to describe the propellant performance. So it is defined as ISP. The formula for calculating the specific impulse is the ratio of thrust to the rate of propellant flow. So in today's propulsion system, it makes use of the commonly used is of two types. One is monopropellant system, another one is the bipropellant system. The first one is the monopropellant system. In monopropellant system, this is a figure. So in this figure, the propellant system is consists of the pressurized gas. Normally, the hydrogen gases are placed in the propellant chamber, so that will be placed with the high pressure. And for its proper operation, we are using some catalyst. So when the valve is get opened, the pressurized hydrogen gas is made to move towards the catalytic chamber. So here the fuel as well as oxidizer both are of same material. So in this monopropellant method, the fuel as well as oxidizer are of hydrazine. So once the filter is opened, the gas that will be flow through the catalytic chamber, and the chemical reaction will take place and produces or it decomposes into hydrogen as well as nitrogen gases. And then these gases will be made to pass through the thruster chamber, so that it will generate the thruster in the satellite. So second type of propellant is the bipropellant. So bipropellant operation of this bipropellant is almost same as that of the monopropellant. The only difference is here in bipropellant they place the oxidizer as well as fuel in different locations. But in case of monopropellant, both the oxidizers and the fuel are placed in a single chamber. A single material is used, but here both are made up of different materials. So first of all, the fuel tank that is filled with the materials, that is we can use the next is the oxidant tank. So the oxidizer is placed in the oxidation tank. So when the valve is get open, both the fuel as well as the oxidizers are made to flow towards the engine of the satellite. So once it reaches the engine, the decomposition takes place. So here the chemical reaction of the fuel as well as the oxidizer will be taken place, and it produces a large amount of gases with a high pressure, and that will make to flow towards the nozzle, and there because of this the uh, thrust will be provided to the system, so that in case of any deviation that will be identified, and that will be rectified.